In this video, I'm going to be discussing compound angles and double angles. There are 6 basic compound angles. Here they are. The first one is sine A plus B in brackets equals sine A cos B plus cos A sine B. The second one is sine A minus B in brackets equals sine A cos B minus cos A sine B. The third one, cos, then A plus B in brackets equals cos A cos B minus sine A sine B. The fourth one, cos A minus B within parentheses equals cos A cos B plus sine A sine B. The fifth one, tan A plus B within parentheses equals tan A plus tan B over 1 minus tan A tan B. And the final one, tan A minus B within parentheses equals tan A minus tan B equals 1 plus tan A tan B. So we can see a similarity between the sine and the tan. For sine A plus B, we can see that the sign between the products is a plus. So the same applies for a minus. And also for tan, plus, plus, then the denominator is minus. Then minus, minus, then the denominator is plus. But for cos, there is a reversal. For cos A plus B, we've got a difference between the products. And for cos A minus B, we've got a sum of the products. And so we can see here, so you can just like go through all of this to familiarize yourself with the particulars of each of the formulas. Okay, so these are the 6 compound angles. Now we can rely on the compound angles here to obtain versions of the double angles. The double angles are derived from letting A to be equal to B in equations 1, 3, and 5. Of course, if we let A to be equal to B in equations 2, 4, and 6, what we are just going to have will be the values of sine 0, cos 0, and tan 0. Focusing on equation 1, we know that sine A plus B is equal to sine A cos B plus cos A sine B. Now, if I let A to be equal to B, so the implication is that I can just replace A by B or replace B by A, whatever. So I'm just going to replace B with A. So in place of B, I'm going to have sine A plus A, that's the left side. So this is going to give sine A cos A plus cos A sine A. A plus A is 2A, so the left is sine 2A. Now, sine A cos A is the same as cos A sine A. It's just like saying xy plus yx. Thus, adding sine A cos A plus cos A sine A, this is just going to give 2 sine A cos A. This is the first double angle. Sine 2A equals 2 sine A cos A. Of course, A is an angle. To make it more general, we can just make it theta. So sine 2 theta equals 2 sine theta cos theta. The same reasoning can be applied to obtain the double angle for cos 2A. So I'm going to focus on equation 3. So we want to prove the second one. So I'm going to put A equals B in equation 3. So the left side of equation 3 is cos A plus B. So since B equals A, the left side is going to be cos A plus A. And the right side would be, of course, I've got cos A cos B here. So that's just going to be cos A cos A. This is cos A cos A. There is a negative sign. This is sine A sine B. It becomes sine A sine A. So this is sine A sine A. Cos A plus A is cos 2A. Then cos A times cos A. This is cos squared A minus sine A sine A. This is sine squared A. Of course, I can leave my answer in this form, but it's not going to be as tidy as I want it to be. So I'm going to recall that sine squared theta plus cos squared theta is equal to 1. So since A is my angle here, I can just replace theta with A. So I have sine squared A plus cos squared A equals 1. So it depends on what I want to leave my answer as. For example, if I make sine squared A the subject, this is going to give 1 minus cos squared A. Since sine squared A equals 1 minus cos squared A, cos 2A is going to be cos squared A minus, so this becomes 1 minus cos squared A. So expanding this is going to be cos squared A minus 1. Minus minus is plus, plus cos squared A. Cos squared A plus cos squared A is 2 cos squared A, then minus 1. So we can see that the double angle of cos 2A is equal to 2 cos squared A minus 1. Of course, I can choose to leave my answer in terms of sine squared A. So already we know that cos 2A equals cos squared A minus sine squared A. And since sine squared theta plus cos squared theta, in this case A equals 1, I can also make cos squared A the subject, and this is going to be 1 minus sine squared A. So if I fix it into this equation right here, cos 2A is going to become, so in place of cos squared A, I have 1 minus sine squared A. Then I've got a minus sine squared A. So this is going to be 1 minus sine squared A minus sine squared A is minus 2 sine squared A. So this tells us that cos 2A can be expressed in two ways. The first one is 2 cos squared A minus 1, and the second is 1 minus 2 sine squared A. If you want to see how I obtained this identity, sine squared A plus cos squared A equals 1, just click on the link at the top right hand corner of your screen. Okay, so we can also focus on equation 5 to obtain the double angle for tan 2A. Already we know that tan A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. As usual, if I let A to be equal to B, then I'm going to have tan A plus A on the left side equals tan A. So in place of B, I would have A. So that's tan A plus tan A divided by 1 minus tan A. Instead of tan B, I would have tan A because A is equal to B. The left side becomes tan 2A because A plus A is 2A. So the right side at the top, tan A plus tan A is 2 tan A divided by 1 minus tan A times tan A is tan squared A. This is the double angle for tan 2A. Of course, I mentioned earlier that if we were focusing on equations 2, 4, 6, what we'd be getting would be the values of sine 0, cos 0, and tan 0. For example, since sine A minus B is equal to sine A cos B minus cos A sine B, if I let A equal to B, what would happen is that the left becomes sine A minus A equals sine A cos A minus cos A sine A, because A is equal to B. A minus A is 0, so this is sine 0. Sine A cos A is the same as cos A sine A. As I mentioned earlier, it's just like saying x times y minus y times x. So this is 0, and of course we know that sine 0 is 0. If we follow the same approach for cos A minus B, if we let A equal to B, we would get cos 0 equal to 1. And if we do the same for tan, we will get tan 0 equal to 0. And you can verify each of these on your calculator. The next thing we're going to do now is to rely on these double angles to solve one or two problems. The question is asking us to express these problems in short form. To solve this problem, we are going to be relying on the knowledge of special angles, especially 30 degrees, 45 degrees, 60 degrees, and of course we would be needing 90, perhaps 180. We could need 270, 360. So these angles are key to solving these problems because we may need to express each of these numbers as either sums or differences of these special angles. For example, 15 can be written as 45, which is a special angle, minus 30, which is another special angle. So in solving the first one, I'm just going to replace 15 with 45 minus 30. So it's quite obvious that this looks very much like sine A minus B. And of course, we know what sine A minus B is. It's sine A cos B minus cos A sine B. Thus, sine 45 minus 30 in brackets would be sine 45 cos 30 minus cos 45 sine 30. Going by this definition, we know what sine 45 is. Sine 45 is 1 over root 2, which is the same as root 2 over 2. Cos 30, that's root 3 over 2, minus cos 45, that's also root 2 over 2. Sine 30 is 1/2. I derived all of these in a video. To see it, just click on the link at the top right corner of your screen. Multiplying these, root 2 times root 3, that's a root 6, over 2 times 2 is 4, minus root 2 times 1 is root 2, 2 times 2 is also 4. Since the denominators are the same, this becomes root 6 minus root 2 over 4. And of course, I can write this as 1 over 4 brackets root 6 minus root 2. This is the value of sine 15 in short form. Focusing on the second one, that's the cosine of 135. I'm also going to be relying on those special angles, sort of. Now, 135 can be written as 90, so we've got a number of options. I can write it as 90 plus 45. In fact, I can write it as 180 minus 45. That's still 135. So the choice is going to be to pick amongst these two. I'm going to go with 90 plus 45. Thus, in place of 135, I'm going to have cos 90 plus 45. Now, this is a sum. It looks very much like cos A plus B. And we know what this is. This is cos A cos B minus sine A sine B. So cos 135, which is cos 90 plus 45, becomes cos 90 cos 45 minus sine 90 sine 45, because A is 90 and B is 45. We know what cos 90 is. Cos 90 is 0 times cos 45, that's root 2 over 2, minus sine 90, sine 90 is 1, times sine 45, that's root 2 over 2. This tells us clearly that cos 135 degrees is equal to negative root 2 over 2. You can as well obtain this same answer if you use 180 minus 45. Of course, if you use that, what you are going to have to rely on would be cos A minus B, where A is 180 and B is 45 degrees. So this is just going to be cos 180 cos 45 plus sine 180 sine 45. And if you work your way through it, you're still going to get the exact same answer. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up, share to your friends and colleagues on social media. Don't forget to drop a comment and click on the subscribed icon. To get notified when I upload new videos, kindly click on the all, that's the dark bell button on the subscribed icon. Thank you for seeing it once again. See you in the next video.